testing and evaluation. This is Unit 1, Overview of Entity. Destructive testing. In this type of testing, the component or specimen to be tested is destroyed and cannot be reused. After testing, the component or specimen either breaks or remains no longer useful for future use. As the name suggests, destructive testing includes methods where the components or specimen is broken down in order to determine the physical and mechanical properties such as strength, toughness, ductility, and coldness. Destructive testing is more suitable and economical for mass production, as the cost of destroying a small number of pieces is negligible. It is not economical to do destructive testing where only one or few items are to be produced. Examples of destructive testing: tensile test, compression test, shear test, hardness test, impact test, bending test, fatigue test, creep, torsion, and chemical analysis. What is NDT? As all of us know, NDT stands for non-destructive testing. As its name implies, non-destructive testing means testing of materials without destroying them. In destructive testing, materials are destroyed, but in non-destructive testing, without destroying the materials, testing the materials. Non-destructive test is an examination of an object which will not produce any kind of damage or destruction to the sample, and after testing the material can be reused. In destructive testing, after the testing it cannot be reused, but in non-destructive testing, after the testing also we can reuse the material. Definition of non-destructive testing. Non-destructive testing is the process of inspecting, testing, or evaluating materials, components, or assemblies for discontinuities or differences in characteristics without destroying the serviceability of the part or system. In other words, when the inspection is completed, the part can be used. In non-destructive testing, after the testing, the part cannot be reused, but in non-NDT, it can be reused. Destructive testing, it cannot be reused. NDT is a procedure which covers the inspection or testing any material, component, or assembly by means which do not affect its ultimate serviceability. For what purpose it is manufactured, we can use it after the non-destructive testing. That is the main advantage of non-destructive testing. Objectives of non-destructive testing. Many objectives are there. Some of them are: first, material sorting, material characterization, material property monitoring, thickness measurement, defect detection and location, defect characterization. Major task of NDT is to detect and identify the range of defect. Some of the major objectives: to detect internal or surface flaws, to measure the dimensions of the specimen, to determine the material structure or properties. Uses of NDT methods: flaw detection and evaluation, leak detection in pipelines or equipments, etc. Location determination, dimensional measurements, structure and microstructure characterization, estimation of mechanical and physical properties, stress, strain, and dynamic response person, material sorting, chemical composition determination. Entity. Entity allows parts and material to be inspected and measured without damaging them because it allows inspection without interfering with the product final use. And it provides an excellent balance between quality control and cost effectiveness. And what is NTE? NTE is nothing but non-destructive evaluation. It's a term that is often used interchangeably with NTT. However, technically NTE is used to describe the measurements that are most quantitative in nature. For example, NTE method would not only locate a defect, but it would also be used to measure something about the defect, such as size of the defect, shape of the defect, and an orientation of the defect. NTE may be used to determine material properties such as fracture toughness, formality, and other physical characteristics. When are NTE methods used? There are NTE application at almost any stage of application or life cycle of the component. To assist in product development, to screen or sort incoming material, that means raw materials, to monitor, improve or control manufacturing processes, to verify proper processing such as heat treating, to verify proper assembly, to inspect for in-service damage. Next topic is applications of NTT. To ensure product interchangeability and reliability, to control manufacturing processes, to lower production cost, to maintain a uniformity in quality level. NTT tests can be performed during the manufacturing process and also after manufacturing process, even on parts that are already in service. Some of the common applications of NTT: inspection of raw materials or raw products, inspection following secondary processes, and in-service damage inspection. Inspection of raw products. Inspection of raw products means raw materials in forging, casting, extrusion, etc. And inspection following secondary processing. Secondary processing techniques such as machining, welding, grinding, heat treating, plating, coating, etc. Next, inspection for in-service damage. Cracking, corrosion, erosion, and wear, heat damage for the components or products which are in service or which are in use. Next topic is features of NTT. Using NTT, an entire production lot can be inspected, or samples can be inspected. Also, different tests can be applied to the same item. That is the very important advantage in non-destructive testing. Either simultaneous or sequentially, and the same test can be repeated on the same specimen for additional verification, but it is not possible in destructive testing. Here in non-destructive testing, we can use the same test repeatedly, or we can use many tests in a same specimen. Yet it may be added that the NTT equipment is often portable. This permits the use of NTT methods for on-site testing in most locations. And NTT does not permanently alter the specimen being inspected. It is a high variable technique that can save both time and money in product evaluation. troubleshooting, and research. And it makes components more reliable, safe, and economical. Advantages of entity. The equipments are easy to handle. Defects can be detected without damaging the components. Methods are fast, quick, and accurate. Components can be sorted out on the basis of electrical, magnetic, or chemical properties. Test results and other informations can be conveniently recorded on paper films, cassettes, floppies, DVDs, or CDs, etc. Difference between destructive and non-destructive test. Non-destructive test used for finding out defects of materials. Destructive test used for finding out the properties of the materials. Load is not applied on the material in non-destructive testing. And in destructive testing, load is applied on the material. No load application, so no change for material damage. Due to load application, material gets damaged in the destructive testing. No requirement of special equipments in non-destructive testing. Special equipments are required. Some of the examples of non-destructive testing are dye penetrant, liquid penetrant testing, ultrasonic testing, or radiographic testing. Examples of destructive testing: tensile test, compressive test, corners test, etc.